Hi everybody, so in today's video, this is going to be the review topic number 5 for Unit 2, which is all about describing features of functions. So the big idea for today is that we can actually tell some of what is going on with a function, so some features of the function, by just looking at the equation. So let's start with this first type of equation. This first type of equation is going to be a linear equation. And I know that this is going to be a linear equation because when I look at the equation, there is no exponent. So this is going to be a linear equation because there is no exponent in the equation. Now, when we have an equation like this that is a linear equation and there is no parentheses in the equation, we call this type of equation slope-intercept form. And again, this is because there is no parentheses in the equation. That means that when we look at this equation, we should be able to figure out two pieces of information. The first thing we should be able to figure out is what is the slope of the equation, of the line. And the second thing we should be able to figure out is what is the y-intercept of the line. So let's talk about where you would find that information in this equation of a line. When you're looking at this equation and you're looking for the slope will always be the number that is multiplied by x. This is again always going to be the number that is multiplied by x. Now this number is not always first. In this equation, it is the first number in the equation, but it is not always the first number in the equation. It just sort of depends on the equation you're looking at. It could be the first number or it could be the second number, but it's always the number that's multiplied by x. Now, in this equation, again, the second number we're going to look for is the y-intercept. And the y-intercept will always be the number that does not have an x. The y-intercept is going to be the number with no x. This is not always the second number. It could be the first number. It just depends on the order that that person who wrote the equation decided to go in, but it's always going to be the number that doesn't have an x. Now, when you look at the coordinates on a graph for the y-intercept, the coordinates will always start with 0, and then the number from the equation will be the y value. So when you look at a y-intercept, this first number will always be 0. For the y-intercept. The other thing I might ask you to do with this type of equation is plug in some numbers. So let's talk about how we would plug in some numbers. In this equation, we know that we can find the y values by using the equation -2 times x plus 7. Now the first number that I'm asking you to plug in here is a -4. So in this equation, what you're going to do is take out the x, did you see that I just erased it? And replace it with a -4. After that, you're just going to type this in on your calculator. When you type this in on your calculator, you should get 15. And so your answer here would be 15. To get the next number for this table, again, I'm going to start with the original equation, -2x plus 7. But this time, I'm going to plug in the number 0. So I'm going to erase the x. Did you see I just erased the x? And I'm going to plug in the number 0. When you plug in the number 0, you just get 7. The last number we're going to plug in here is the number 8. So I'm going to take this exact same equation and I'm going to copy it down. Y equals negative 2x plus 7. I'm going to erase the x and I'm going to replace it with the number 8. When I do that, I get negative 9 as my answer. Okay, so that's sort of the first style of equation is what's called slope-intercept form. We know that it's slope-intercept form because there's no exponent and there's no parentheses, which means when we look at this equation, the two pieces of information I might ask you about are the slope and the y-intercept. The second type of equation looks like this. Now, just like the first equation, this is also a linear function. And the reason I know that is because, again, this equation does not have an exponent. It's just a different style of linear function. This style is called point-slope form. The reason it's called point-slope form is because instead of finding the y-intercept in this equation, we're going to find some starting point. It just won't be the y-intercept of the graph. And I know that this is a different form called point-slope form because there is a parentheses in the equation. Now, since this is point-slope form, we're still going to find two pieces of information. We're going to find the slope, just like we did before, and we're going to find the starting point. Now, just like in our first example, the starting point is going to be an ordered pair where we start on the graph. It's just that this time your starting point will not be on the y-axis. It will not be the y-intercept. So in this equation, you're going to find the slope by looking at the number that is right outside of the parentheses. This is going to be the slope. This is going to be the number that is multiplied by the parentheses. It is not always in the middle. It could be in a different spot in the equation, but it's always going to be the number that is multiplied by the parentheses in the equation. Now, in this problem, we're still going to find a starting point, but our starting point is going to require us to find two numbers. A starting point is going to have an x value and it's going to have a y value. The x value of your starting point is always going to be in the parentheses with the letter x. But this number is always going to be the opposite of the number you see. So this is going to be inside the parentheses, and it's going to be the opposite of the number that you see. So if you see the number positive 5, then this would actually be a negative 5. If you see the number negative 5, it would actually be a positive 5. Now, the y coordinate of your starting point is going to be the number that is not attached to the parentheses in any way. In this case, it would be the number 10. It is not attached to the parentheses. It's not inside and it's not multiplied. It's like sort of a separate number. It is not always the first number. It could be at the end of the equation, but it's the number that's not attached to the parentheses. Now, just like in the first problem, sometimes I'm going to ask you to plug some numbers into this equation. So my first number that I'm trying to plug in here is the number negative 8. What I'm going to do is take my equation, y equals 10 plus 1/3 times x plus 5. And all I'm going to do is erase the x and put the number negative 8 there instead. After that, I'm going to use my calculator and I'm going to type this in. And when I do that, I should get the number 9. Next, I'm going to plug in the number 0. So again, I'm going to just copy my equation, y equals 10 plus 1/3 times x plus 5. I'm going to erase the x and I'm going to replace it with the number 0 because that's the number I'm plugging in. And when I do that, again, I'm on my calculator and I'm doing this, I should get 12.6 repeating. Oh, I'm sorry. No, it's not 12.6 repeating. It is 11.6 repeating. And so that would go in this box right here. The last thing that I would do is I would again copy this equation, y equals 10 plus 1/3 times x plus 5. And I would just replace that number with the number 4. So I'm going to erase the x and I'm going to put the number 4 there instead. When I do that, I should get 13 as my answer, and that would go in this box right here. Now, the last type of equation that we're going to look at looks a little bit different. You'll notice that this equation is not a linear equation anymore. This is going to be an exponential equation. And the reason that I know that is because there is a parentheses. I'm sorry, there is an exponent. In an exponential equation, there are two pieces of information that we're going to find. We're going to find the starting y value of the equation, and we're also going to find the multiplication pattern. So the starting y value is always going to be the number that is not connected to the exponent. So in this case, it would be the 2/3. So the starting y value would be not connected to the exponent. The second number that we're going to find is the multiplication pattern. In this case, that's going to be the 5. This is going to be the number that is the base of the exponent. So anytime you see an exponent, the multiplication pattern is always going to be the base. Now, another thing I could ask you to do with this equation is plug in some numbers. So if I wanted to evaluate this equation for when x is -1, I would copy my equation, which is 2/3 times 5 to the x power. And I'm going to erase the x, and I'm going to put a -1 there instead. And now I'm going to use my calculator. When I type this in, I get 2/15. The next thing I'm going to do is I'm going to replace the x with a 0 instead. So I would have y equals 2/3 times 5 to the x power. I'm going to erase my x and I'm going to put a 0 there instead. When I type that in on my calculator, I get 2/3. Now, for those of you who are using a calculator and getting decimals, that would be 0.6 repeating. Those mean the same thing. Last but not least, I'm going to replace my x with a 2. So I would copy my equation, y equals 2/3 times 5 to the x power. I would erase my x and I'm going to put a 2 there instead. When I do that and I type it in, I get 50/3. Now, 50/3, for those of you who are maybe using a calculator and getting a decimal instead, would be 16 point, let me do this in my head, 0.6 repeating. All right, that is it for our video today. Thank you guys so much for watching. And the next thing you're going to do is try the practice problems on the next few pages of your remediation packet.